Hey folks, Mr. Hartzler here. I want to do this video on operations of functions. So we have four main operations. We have addition, subtraction, multiplication, and division, and they're all treated pretty much the same as all of the other times we use them. So when we're adding f and g of x, well, it's just the same as splitting up f and g and adding them together. Same thing with subtraction. F minus g of x, well, that's the same as f of x minus g of x. Multiplication, same. Division, the same. Division can be a little tricky though, because our denominator is not allowed to equal 0. Because in that case, f divided by g of x would be undefined. So we always have to check that denominator, make sure our denominator is not allowed to equal 0. And if there's something down there, if there's an x down there, we have to set that not equal to 0 and then have that restriction in our domain. So let's get started on some examples. So if f of x is x squared plus 5x minus 2, and g of x is 3x minus 2, find each of these functions. So this is the case where we're adding them up. Let's see if we can switch colors around in here. Let's say that we're splitting this up then to f of x and g of x. And all we have to do now is label both of those things. F of x is x squared plus 5x minus 2, while g of x is 3x minus 2. Combine anything that happen to be like terms, and we have 5x and 3x, and our constants of -2 and -2. And x squared, that just comes down. Combining these two, we now have 8x. -2 minus 2 more is a -4. That one, done. Since we didn't have any weird denominator, no square roots or anything, there's no restrictions in our domain or in our range. The next one, f of x minus g of x. Similar thing, I'm going to split this up first, f of x minus g of x, and then I just write in what f of x and g of x are. So that's x squared plus 5x minus 2. And g of x is, put a big minus out in front, 3x minus 2. In this case, I've got to distribute that negative sign in. So I now have x squared plus 5x minus 2 minus 3x plus 2. Then I can combine any like terms that I might have. We have our x's, and we have constants. X squared, 5x minus 3x gets me a positive 2x. -2 plus 2 gives me nothing, 0. So that is my final answer. Again, there's no restrictions in my domain or my range because there's no square roots and there's no denominators. Next one here. Given f of x and g of x, find each of these functions, and we do have to indicate some restrictions. We might have some over here. So when we multiply them, same thing we've been doing in the past. F of x, and then we multiply that to g of x. Then I plug in what those two things are. F of x being x squared plus 5x plus 12, and g of x being 2x minus 1. Now I have to FOIL all of this, is what some people say, or distributing, because I have all three of these terms. I have to multiply to all two of these. So this x squared gets multiplied to both of these. That's x squared times 2x, so that's now 2x cubed. X squared times -1, negative x squared. 7x times 2x, that's going to be 14x squared. 7x times -1, that's -7x. I have 12 times 2x, that's plus 24x. Then I have 12 times -1, that's -12. Then I combine any like terms. Nothing with the 2x cubed, so that just comes down. I have an x squared and an x squared. So that's plus 14. Oh, sorry, plus 13 of them. I have some x's. That ends up being 17. And then only one set of constants. There we go. So 2x cubed plus 13x squared plus 17x minus 12. And there are no restrictions in my domain and range because there are no sine and cosine, or sorry, not sines and cosines. There's no square roots or fractions. Now we have f of x divided by g of x. F of x being x squared plus 7x plus 12. And we divide that by 2x minus 1. In this case, when we're dividing, we can sometimes do some simplification. So I want to factor my numerator if I can help it. And this one does factor. It factors to x plus 3, x plus 4. And then my denominator is still the same, 2x minus 1. It doesn't factor any. Since nothing on top and bottom cancels, I know it doesn't simplify any further. So that is my final answer. But I do have to note that there is a restriction. For my domain, x can be all real numbers such that x cannot be what? Well, x can't be something where my denominator is then a 0. So 2x minus 1 is not allowed to equal 0. Add 1 over. 2x cannot equal 1. Divide by 2. So x cannot equal 1/2. X can be anything it wants such that, I don't know why those markers keep rolling around. X can be all real numbers such that x can't be 1/2. X can be anything it wants except 1/2. Alright, hope that was helpful for you all. And this is, for me, it's chapter 6 in my textbook, and then that's the first section. It also has to do with composition of functions, but we'll get to that in another video. And when I do, I'll link it below. Hopefully this was helpful, and if it was, please click that like button. If you want to see more tutorials like this, subscribe to my channel. And of course, everybody, I hope you have a great day and enjoy the nice weather that I happen to be having here.